So didn't I have to get them so that they all like multiplied to be the same one? Like they have like the common denominator and stuff.
Yes. So this is basically like adding fractions in reverse. So they currently have the common denominator, and you have to say like what plus what would have given you that answer. Any idea what the two denominators would have been?
1 plus x and 2 minus x.
Yeah. Okay. Any idea what you do next?
Would I do like? Would I say like I need to times them by 2 and minus 1 to get? I know. No, by 2 and minus x. Or no.
Basically just adds the two on the right. Like, yeah, just add the two on the right in terms of A and B.
And so would that be a plus b over do I need to get the denominators to be the same first? Or?
Yeah.
So do I need to like times a by 2 or something?
So you would times A by 2 minus x over 2 minus x. So, yeah, A times 2 minus x. So it's like cross multiplying.
Yeah. And b, okay, yeah. Oh, and then you just end up with a with 2a minus ax and plus b plus x plus bx. Yeah.
I'll just leave it like that for the sake of simplicity. And then that's over that. Okay, compare the two. If you compare the numerators, you can see that 4 minus 5x is the same as this.
Is this right? I've been numbers like 0 and stuff to get what the other letters are.
Yeah. So what would you sub in for x?
Minus 2. Just two, sorry.
Yeah.
And then that would give that minus 6 is equals to 3b.
Mm-hmm.
And then b is equals to minus 2.
Mm-hmm.
And then would you sub in x equals to minus 1?
Yeah.
And then you'll get. I might just start putting it into my calculator to make sure anything.
Yeah. You could also like replace b with minus 2 and put the whole thing in your calculator.
Oh yeah, yeah.
Whatever's quicker and easier. I think A is 3 as well. Might be 1 over 3. I think it's 3.
Yeah, A is 3.
So A is 3, B is minus 2. And so what is this as partial fractions? Or what is that?
Would it be like 3 over 1 plus x plus, or even minus 2 over 2 minus x?
2 minus x. That's it. I'm just going to copy. Ooh, not that much. Can I make me copy all of it? All right. 1 second. So that was our answer. Oh. No. Yes. Okay. Let's use our answer for part B.
So it says hence. So I know I need to use this answer here.
Yeah.
Do I need to get the denominators to be like multiplied by 3 and 2, so they're on the same level? So there's the denominator is just 1 basically.
That would be going back to the original question. Binomial expansion. How would you have expanded 3 over 1 plus x if it was by itself?
But I've just done. There's like a formula, isn't it?
Yeah, but what is step 1 before you do the formula?
You do 3 and then 1 plus x to the power of whatever, x to the power of whatever, or minus 1, yeah.
Yep.
Oh, yeah, power of minus 1.
That's it.
And then I'd use the formula here.
Yes. Do you remember this formula?
No.
I'll never forget this formula though.
Yeah.
Oh, excuse me. Okay. So they want it up to x cubed.
So would I then do here 1 plus. Oh, I need to get, so the n is minus 1 and a is 1 as well.
A equals 1, n is minus 1.
So would I then do here 1 plus minus 1 times 1x,
Mm-hmm.
and then plus minus 1 times minus 1 over 2 factorial.
Yep.
And then oh yeah, and then 1x squared, and then plus minus 1 times minus 1 times minus 1 minus 2 over 3 factorial.
Yep.
And then 1x cubed, and then just plus dot dot dot.
Yeah, so you could go forever, and they just set up to x cubed.
And now to simplify that, it would be 1 minus x, and then I'll start using my calculator here.
Okay. What's this thing doing? I just want to close some stuff on my computer. Zoom. Hopefully that's okay.
And then I got plus x squared.
Okay. That's plus x squared. And then this one is minus 3 times minus 2. It's going to cancel out. I think it's just minus x cubed.
Yeah.
Okay. So we did that for 3 times 1 plus x to the minus 1.
And now I need to do I now need to times that by 3?
Yes. Well done. I forgot about it.
And so that would be 3 minus 3x plus 3x squared minus 3x cubed.
That's it.
And do I now need to do it for the second?
Yeah.
And so it'll be 2 times 2 minus x to the power of minus 1.
Yeah. So this was 2 times 2 minus x. 2 times 2 minus x. Okay. X to the minus 1.
And then, so will it be a is 2 and n is minus 1?
Let me see. Our formula, a is not 2. A is the number in front of x. However, our formula is for 1 plus only.
Oh yeah. So I need to factorize 2.
Yeah.
So will it become like 4 and then brackets 1 minus a half x?
That is 1 minus a half x to the minus 1. You forgot a little thing. The bracket is to the minus 1. So when you factorize out 2?
Um.
You factorize out 2 to the minus 1.
Oh, right. Okay.
Because it was in a bracket with that. Okay.
So now do I need to do... So... wait, so is here a is minus a half and n is minus 1?
Yep.
So would it here be 1 plus minus 1 times a half x?
Yeah.
And plus minus 1 times minus 1 minus 1 over 2 factorial.
Mm-hmm.
And then minus a half x squared.
Mm-hmm.
Plus minus a half times minus a half minus 1 times half minus 2 over 3 factorial.
It's not a. It's
Oh,
n.
sorry. Sorry. Minus 1 times minus 1 minus 1 times minus 1 minus 2 over 3 factorial times minus a half x cubed.
That's it. You did a cube one. I'll do the square one.
Cool.
Let's see. Whoops.
I got an 8x cubed.
Okay. I'm getting a quarter. Is your one plus or minus?
A plus.
So I think I'm getting plus a quarter x squared. You're getting plus an eighth x cubed. We always have 1. And then what about this x?
Probably be just plus half x.
Okay. Kind of has a pattern to it. And let me see. So that was that one. Our first answer was 3 3, 3, 3. So our first answer was 3. I think it was minus 3x plus 3x squared minus 3x cubed. Originally, yes, in partial fractions, our answer for part A, 3 over 1 plus x. It was 3 over 1 plus x, and that was minus 2 over 2 minus x. What do we do with our two answers?
Add them together.
Subtract, because it was minus. Because b was minus 2.
So will it be 2? Will the first answer be 2?
Mm-hmm.
And then minus 3.5.
Yeah, I'll write it as 7 over 2.
Minus 2.75. Oh no, plus 2.75.
Yeah, 11 over 4.
And then minus 3.125.
Yeah, minus 25 over 8 x cubed. And what were we supposed to get?
Yeah, the answer they wanted, basically.
Yes. Okay, and then part C.
Is this where you have to do like magnitude of x is smaller than something?
Yeah.
So will it here be magnitude of x? Does it matter? Is it like whichever one is the smaller of the a's?
Yeah.
And I forgot what the other a was.
I think it was 1. Yeah, the other a was 1.
So will it be the magnitude of x is smaller than a half?
So a was a half. I think it's the other way around. The magnitude of ax, so a half x, is less than 1. So what is the magnitude of x?
Smaller than 1 over a half.
Yep. What's 1 over a half?
2.
Yep. I just eyeballed that. Hopefully that's correct. Because we were kind of doing it in reverse. So we're silly, sorry. So what was the smaller one then?
1. Oh.
Yeah, so actually the magnitude of x was smaller than 1. Turns out to be the smaller of the two. Yeah, because it was a half. A was a half this time. Or minus half. But it's magnitude, so it's just going to be plus. Okay, big picture. Partial fractions. So you have to remember how to do partial fractions. They give you the answer. You have to pull them apart. Figure out what the original two fractions were. You do the first, so you write them in the form of times their denominator to the power of a minus. Do the first expansion, do the second expansion, and this was the first to take away the second.
Yeah.
And you get your answer that way. And actually, let me just see. We got real lucky, Andrey. Do you know how? What is 2? We forgot. You know the first one, we multiplied it by 3.
Yeah, it's because 2 times 2 to the power of minus 1 is 1. So we didn't have to times anything, yeah.
Did you remember that, or did you just figure that out now?
I popped into my calculator and I was lucky. I thought you assumed that, and I was like, okay, so he already knew, basically, so.
Yeah. Then in that case, yeah, I already knew. There we go. Lucky. All right. Any questions there?
No.
Okay. Let's see. Exam question. Let's see. Where is my formula? And in fact, I even forgot to multiply by the 3. You reminded me on it. Right, let's try this.
So, do I now just need to do... so I now need to like put times them together, don't I? Do I need to do a times 1 minus 3x over 1 plus 2x, 1 minus 3x? And then the same for b, just that times by 1 plus 2x?
Yes. 3x plus b times 1 plus 2x. Yep.
And then equals to 12x minus 1.
Yeah.
And then now I just need to do like... What's that? Do I now need to do like x is equals to a third and x is equals to minus a half?
Yep.
And so for x is equals to a third, it would be... I'll just put into my calculator now.
Yeah.
I got x is 1 point... Oh, that's right. I got b is 1.8.
What is that as a fraction?
9 over 5.
9 over 5 and 1.8. Okay. A.
And now, yeah, just put the... I now need to just put in 9 over 5 and minus a half into the calculator to get the answer.
You can put in one or the other. If you put in minus a half, then you'll get 0 for the second one, so it won't really matter.
Oh yeah.
It'll work, but you know.
So yeah.
Yeah, so we have to just put in x is minus a half. X minus a half, yeah.
I got the a is minus 2.8.
So a is minus 2.8. What is that as a fraction?
Minus 14 over 5.
5. Okay. What are those written as partial fractions?
Minus 2.8 over 1 plus 2x.
That wounds me to mix fractions and decimals. I'm going to write minus 14 over 5, 1 plus 2x.
Yeah. And then plus 9 over 5 brackets 1 minus 3x.
Minus 3x. I'm kind of wrong actually, Andrey. You're right. They wanted a and b, and so a is 1.8. Sorry, a is minus 2.8 and b is 1.8. Or as a fraction, but they didn't really want it expressed in this way or something. Okay. Maybe I'm wrong. So using a or using any way you like, decimal or fraction. What is question B?
So do I now need to do? So I'm guessing that the way we did it in partial fraction in the end probably helped us for B.
Maybe not. Maybe it's all the same to the calculator. Like, you could write it as 1.8 over, or minus 2.8. So I'll do the other way. Minus 2.8 over 1 plus 2x. Okay, so how do we do this?
So do I need to do minus 2.8 times 1 plus 2x to the power of minus 1?
Mm-hmm.
And then so I now need to put into the formula, don't I?
Mm-hmm.
And so that'll be 1 plus 2 times minus 1x, and then plus minus 1 times minus 1 over 2 factorial times 2x squared. And then I just need to work that out first of all.
Yeah, you're right. Up to x squared.
So it's 1 and then minus 2x. And then plus 4x squared.
Yep.
And then I need to times that by minus 2.8. And then shall I do the next one now?
Yep.
And so that would be 1.8 times 1 minus 3x to the power of minus 1. And then, so that would be 1 plus all right, minus 3 times minus 1x plus minus 1 times minus 1 over 2 factorial times minus 3x squared. And then that will be 1 plus 3x. And will it just end up being like plus 9x squared?
Yeah.
And then times that by 1.8.
Yeah.
And now do I need to expand the brackets and then add them together?
Yep.
So that'll be minus 2.8 times 28 over 5.
Just trying to make more room for myself. Go on, you keep going.
So will the first expansion be minus 2.8
Okay.
plus 28 over 5x and then minus 56 over 5x squared. And then for the second expansion, would it be 1.8 plus 27 over 5x plus 81 over 5x squared? Do I now just need to add and subtract all of these together?
Yeah.
And so that would be minus 1 plus 11.
11.
Just 11.
Not just 11. It was just minus 1.
Oh, 11x, sorry.
Yep.
And then plus 5x squared.
5x squared. Minus 1 plus 11x plus 5x squared. Okay, so these binomial expansion questions are huge, but you nailed it, I think. Any questions there?
No.
Okay. Let me see. State the range of values for which the expansion is valid. So for what range of values was our expansion valid?
So would it be valid for like, I don't know, magnitude of x is smaller than 2 or something?
The magnitude of ax is less than 1.
Oh, at least magnitude of x is smaller than a third.
Yes. So this would be magnitude of x is smaller than a half. This one, magnitude of x is smaller than a third. And so magnitude of x is smaller than a third. Any questions about this one?
No.
Let's see. So this one is exactly the same. It just had the magnitude thing at the end. Oops. Same. This time you've got 3 partial fractions, like a whole number part. Let me take a look at this. But it's just partial fractions, really. Once you have the partial fractions, then you're fine. This one, again, yeah, partial fractions. And once you have that, then it has find the percentage error. Find the percentage error to estimate the value of 0.05. Do you remember how to do percentage error?
Was it like new value minus initial value over initial value times 100 or something like that?
Yes. And so in this case, it would be the f of 0.05, so into the original one, minus 0.05 subbed into our approximation over the original times 100.
Yep.
So there's just more stuff going on, but it's the same. So the only difference here was that it's partial fractions and it's the power of a negative. I suppose this one here, it will be to the power of -2, like 3x minus 1 to the power of -2.
Yeah, yeah.
It's the same. It's the same idea. What is slightly different about this one is hang on. What is slightly different about this one is when you factorize out something like 2 or 3, don't forget to put it to the power of the bracket. So if the bracket was to the -1, then what you factorize out is to the -1. If it's to the power of -2, what you factorize out is to the power of -2. And so partial fractions.
I'll give it a tick.
And that's that one done. That's great. So that's all of binomial expansion. Do we do next thing?
Yes, please.
Next chapter. Okay. Radians, sectors, and segments. So you remember sectors and segments from GCSE. All that theta over 360 times pi r squared. Will I skip? Okay. Radians. Have you seen radians before?
Not really, no.
Oh, okay. It's like the difference between centimeters and inches, except for angles. So instead of degrees, you can use radians. 1 radian is 180 degrees. 2 radians is 360.
Okay.
1 radian is 180 over pi. And a radian is the angle if the arc length was the same as the radius. So 1 radian is 180 degrees over pi. Let me see these. So 1 radian is 180 degrees over pi. And we use that half, like that C. Let's see. So we have to convert this. So let's say pi over 180 would be equal to 1 radian. Okay, so how do we convert 7 pi over 8 into degrees?
So we need to do 7 pi over 8 divided by 180 or something.
So what do you have to do to 1 radian to turn it into 7 pi over 8 radians?
Times it by 7.
Just times by 7 pi over 8. 7 pi over 8. So let's see. Yeah. So let me think about this. So in general, let's say degrees, radians. So to go from degrees to radians, you times by 180 over pi. Hang on, that should be, what is this? This should be degrees. And then to go from radians, pi over 180, yeah, divide by 180 over pi, or times by pi over 180. That's how we do it. And so 7 pi over 8, change it into degrees.
So do I now need to do 7 pi over 8 divided by 180 over pi?
Yeah, give that a go.
I got a bad answer.
That's all right.
So I got 0.04797772.
Am I getting this wrong? Do it as. Did you do divided by 180 over pi?
Yeah, I'm pretty sure. Wait, I'll go back again and do it. But...
Do it as divided by pi over 180. No, I think it should be divided by. No. Divide by. Oh, we'll give it a go the other way. Divide by pi over 180.
Okay, so I got 315 over 2.
Yeah, so 157.5 degrees. So it's actually, sorry, it's the other way around. That one is divide, this one is times. 157.5 degrees. 157.5 degrees. So let's try the other one. That should have been a times.
So so now I need to do 4 pi over 15 times pi over, no, divided by pi over 180.
Times, sorry, divide by pi over 180. Yeah, that'll work.
And I got 4.
So that one is 4 degrees. What? Oh. What did you put into your calculator?
The wrong number.
Okay.
I put 4 over 180 rather than 15. Yes, 48. Yeah, 48.
40 was it?
Yeah, 48. Yeah.
Oh, 48. Sorry. 48 degrees. Okay. There's a reason why I'm so bad at this. Calculator. I'll just do simple one. Shift setup. Angle unit. I change to radians. And if I do 4 shift pi over 15, I get 4 pi over 15. But if I do shift setup and change my angle unit to degrees, I get the same thing and get made a liar of. That never happens. Let's see. And my old calculator, I knew where it was. I'll try to find it in the graphical one.
Yep.
All right. We get the idea. Okay, convert these into radians.
So do I need to do 150 divided by pi over 180?
Give it a go.
It might not be that. That looks a bit. Oh, yeah, this answer looks a bit too big.
What you get?
8,594.
No. Let's see. So degree to radian, divide by 180 over pi.
Yep.
Is that what you did?
No, I did divide by pi over 180.
Okay. Divide by 180 over pi.
Yeah, I got 5 over 6 pi now.
Okay, 5 over 6 pi. And second one.
And so here I got 11 over 18 pi.
Okay, 11 over 18 pi. Hang on a second. Let me go back to my old reliable. So we're in degrees. Let me go back to, so this one's 7 pi over 8. 7 pi. Oh, what mode am I in? Fraction. There we go. 7 pi over 8. Let's put a bracket around everything just in case. And shift, and this DRG, degrees radians gradient, is the third one. That is radians, which is 2. And it just gives me the 157.5. So I'll just have to find the that similar thing in the calculator. It kind of doesn't really come up to convert between the two, to be honest. It's just giving you an understanding, I think. Okay, let's try these. And the way you do it is you just put your calculator into radians. So do you have rad at the top, or is it deg for degree?
So yeah, I've got rad at the top, yeah.
Okay, so put sine 0.3 and it should give you the answer.
And how do I put the rad in?
You don't. It's just in radians mode.
All right.
It's like a unit.
I got like a long decimal number. So I think the answer is 0.30.
I think B won't give you a decimal. Try that.
Oh yeah, I got -1.
-1, and then C is just a 10 thing. Yeah, there we go. 0.30 and -1. So you can see there was no converting involved. Okay, how do you sketch this graph?
I put it into my calculator.
Yeah, and another thing you can now do, because you're now in degrees mode, so I'll put sine x, so you can just do whatever, so you have to make it, so shift view window, I'm going to choose trig.
How did you go to that, sorry?
Shift F3 for view window.
Yeah.
Let's see. So this one, shift. Oh, what did I press? Draw. Let's see, view window. I don't know. I don't know if there's a way to do it. But it's basically, okay, so you do your sine graph. That's usually 180, that's 360, that's 270, and that's 90. Write them in radians.
So I need to do 90 times 180 divided by 180 over pi.
Yeah, and 180 is pi. Can you use that? So that you don't have to do all the other stuff.
So is it just 90 times divided by 1 then?
No. 180 is pi. What is 360?
2.
2 pi. What is 90?
Half pi.
And what is 270?
2/3 pi. Or 3/2 pi.
3/2 pi, yeah. 3/2 pi. And yes, you'll get used to it. 360 is 2 pi. And you can go from there. So yeah, it's just about putting the main points on in radians. All right. The reason why I'm doing this is because this graph that we have here, so pi is 3.14, and so 3.14 is going to be here, like 1, 2, 3, and it's a little after it, but it's not obvious. Like there's probably a setting in there for it to show pi. How would we do this?
I'm guessing we put this into our calculator again.
Yeah, couldn't hurt. I'm just again concerned that it's going to be like same thing as before, that it doesn't say what pi is. So cos graph, what are the main points?
0, 2 pi. I'm guessing that's pi.
Yeah, because it's 180.
And will there be like where 270 is?
Yeah. What is 217?
Is that 3 over 2 pi?
So that's 3 over 2 pi. This one?
2 over 3 pi?
No.
Well, is that a half pi?
Yeah. That one's a half pi. So that's y equals cos x. They want y equals cos x plus pi. What's happened there?
They want... So I need to find the value for x, don't I?
No. What type of transformation is it?
I don't know.
It will be translation.
Okay.
X direction by what vector?
I'm not really sure.
What if it was y equals cos x plus 90?
It would just be whatever cos x is and then 90 to the left.
Yeah. And so in this case, you are taking away pi from all the x coordinates, or it's pi to the left. And so this pi here is now where we're starting from. So we're now starting from -1, going up to there, and then I think going back down.
Yeah.
And then we just put on all our main points again. Pi, 2 pi, a half pi, and 3 over 2 pi. I think that's it. Yes. And so it's moved, yeah. So instead of, it's the same idea. Instead of it being 90 or 180, it's pi or 2 pi or half pi. Any questions about that?
No.
And one thing that might be helpful as well is menu table. So 7. So you could do cos in a bracket x plus pi. Let's see, pi is shift dot x10x. That's my function, and we can set it to start from 0, end at 2 pi, like they said, end at 2, shift pi, and let's say we go up in steps of a half pi. So 0.5 shift pi, and there we go. So 0, that's a half pi, that's pi, 1.5 pi, and then 2 pi, and so you get the -1, 0, 1, 0, minus 1. So minus 1, 0, 1, 0, minus 1. Any questions about that?
No.
Okay. Let's see. So let me just check something. Yeah, there was only one exam question. Okay. How about this one?
So here the vector will just be like cos x and then 2 pi over 3 to the right.
Yeah.
I think.
Yeah. And so they want the x-intercepts.
So that would be. I could just put that into my calculator, can't I?
The graph, is it?
Yeah.
Yeah, give it a go.
I mean, mine didn't have any x-intercepts.
Might just be the way it looks or something. Like it's kind of zoomed. Capture screen. Menu 5. Cos x minus fraction 2 shift pi over 3. I've got lots of roots. Try shift zoom auto. That's what I mean.
So no.
Try shift view window trig.
Window trig. Yeah.
That work?
No, it's just kind of like some sort of weird dots on the calculator. I'm not exactly sure.
I don't get it. Cos graph. What's its usual intercepts?
Oh, like 180, 90, 270, that sort of thing. Or,
Yeah, actually we saw this a second ago. You said that was a half pi. That was 3 over 2 pi. And so these will be symmetrical. And so what will they be after that? Transformations. You said the vector 2/3 pi.
there'll be 2 over that'll be going to the right. So add 2 pi over 3 to the right of each one, or
yeah, you would add 2 pi over 3 to each of those coordinates.
Yeah.
So let's just try. So a half plus 2/3. Why am I so bad at this? 3 plus 4. 7 over 6 pi for one of them.
Yeah.
I don't know where the answer is. 1 sec. Oh, did I put it in? 7 over 6. 7 over 6 pi. Yeah, great. And then let me see. Yes, and so what do you give yourself a radians?
I'll give it a half. I'm not really quite there yet with it.
Okay, you'll get used to it. Believe me.
Yeah.
360 is 2 pi. It's just the same. Yeah, so will we continue this chapter next time?
Yes, please.
Any questions for me in general?
I don't think so.
All right, well done, Andrey. You did great, and have a nice weekend, and I'll talk to you next week.
Cheers, thank you. Bye.
Goodbye.